Hello, welcome back. We're going to continue our discussion. And on AP Review, we're going to take a look at a few integration problems. This is part one. We'll take a look at part two later on. For part one, for example number one, here we are to integrate this x cubed plus 5 over x squared. Now, this should be a pretty easy one. There are a couple ways when I can divide because I have the top is bigger than the bottom, but I can also recognize that the bottom here is a single term, so it's probably easier just to split the fraction, like so. And when we integrate, x becomes, of course, as just x squared over 2, plus this becomes 5x to the negative 1 over negative 1. Remember, we're adding our powers. It's just our basic power rule. If x to the n, this just becomes x to the n plus 1 over n plus 1, plus your constant of integration, which is plus c. So here we get x squared over 2 minus 5 over x plus your constant. There we go. All right, for question number 2 here. All right, I can factor the bottom, and I'm going to go and do that. This becomes x minus 2, x minus 5, and because I can factor the bottom, this is our partial fractions using the Heaviside method. So partial fractions, not that bad to do. So we're going to write this as a over x minus 2 plus b over x minus 5. Now, if you forgot how to do partial fractions, you can look at another video of mine, plus 10. Multiplied by the common denominator, we get a times x minus 5 plus b times x minus 2, and that's just going to equal 1. If we let x be 5, this just becomes 0, and we wind up with 3b equals 1, or b equals 1/3. If we let b equal 2, we're going to get negative 3a equals 1, or a equals negative 1/3 right here. And all this does is just rewrite our integral. So now we get negative 1/3 over x minus 2 plus 1/3 over x minus 5 dx. And I'm going to factor out this negative 1/3, makes it a little bit easier for me. 1 over x minus 2 minus 1 over x minus 5 dx. And now I can integrate. This is just our natural log now. So we're going to get negative 1/3, the natural log of x minus 2, minus the natural log of x minus 5, and don't get that, plus your constant. And you can simplify this. You get negative 1/3 times the natural log of x minus 2 over x minus 5, plus your constant. Let me kind of clean this up, make it look a little bit nicer. There we go. And there we go. There's our answer. You can leave it right here too. All right, example number 3 here, if we take a look, this is our u substitution. Because if I take the derivative of 8x squared, I get 16x. That's going to cancel with this outside x here. So I'm going to u equal 1 plus 8x squared. My du is 16x dx, so dx is du over 16x. Those x's, like I said, would cancel. And I'm going to go ahead and change the domain when x is 0. Remember, this is x is 0. U is going to be, plug it in here. 0 is just going to be 1. When x is 1, plug in here. We're going to get 1 plus 8 times 1, which is just 9. So u is 9. And that's going to become 1/16 u to the 1/2 du. Now I changed my domain. You didn't have to, but that's okay, and that's all right too. When I integrate, we get 1 over 16. We get u to the 3/2 times 2/3 from 1 to 9. Cancel, cancel. It becomes 8. So we get 1 over 24. U to the 3/2 from 1 to 9. Use your FTC. F of 9 minus f of 1. And we get this 1 over 24. And I'm going to plug in 9. The square root of 9. The square root of 9 is 3. 3 cubed is 27. Minus just 1. And you can simplify that. What do you get? 26 over 24. Or what's that? 13 over 12 if you want to reduce it. This is fine as well. All right, hope you guys enjoyed the video. We'll come back. We're going to take a look at a little bit more. We'll take a look then, and we'll take a look at a few more. I'll see you then. Bye-bye.